Here we're going to look at the role of a firewall in network security and a few different firewall types. Originally, the term firewall comes from a wall that was built in order to stop fire from spreading from room to room. You'll see that a lot in commercial construction, things like that, firewalls. In terms of network security, the role of a firewall is to block unwanted traffic while still allowing any authorized or desirable traffic. Okay, and all of that will be based upon your security policy. So one of the first things you want to do before you even delve into configuring your firewall, I should say first deciding the type of firewall or firewalls that you'd like to use. And before configuring them, you're going to want to decide what are the policies, what are your access policies for your network. Don't let the firewall product drive your policies, your access rules. Okay, so your firewall product may do some really cool things you're really interested in, but you may not have the expertise or the need for any of those things. So make sure that your security policy is written first and your access policies are written first. Then you use that in order to configure your firewall and honestly, quite honestly, the rest of the security in your network. So the three main types of firewalls we're going to look at are packet filtering, stateful, and application gateways. A packet filtering firewall filters packets on layer 3 and 4 information. We'll look at that more in just a minute. A stateful firewall goes one step further and actually keeps track of the state. A packet filtering firewall either permits or denies the traffic based upon what you configured, or the packet. So once that packet is permitted or denied, no other information will then be kept on that. With a stateful firewall, it keeps track of the whole connection. Right? So inbound, it comes in at a particular port, and it goes out, and then it can return on that particular port, and it keeps track of that information in its state tables. And then last, an application gateway filters at layers 3 to 5 and 7, sometimes called an application proxy. A connection is made to a proxy server, and basically the proxy server discusses with the outsider, the untrusted network, the things, makes that connection, and works on behalf of the inside host. Okay, and we'll look at that more here in just a second. There's other things, host-based firewalls. A lot of your computers, I would guess, I know your Windows computer has a firewall on it. Whether or not you turn it on is up to you. And you have other software-based ones that you can buy, transparent firewalls, things like that. So mainly we're just going to look at these three. Before I move on to the advantages and disadvantages of a packet filtering firewall, I want to go through and just further explain these types. So as we said earlier, a packet filtering firewall filters packets on layer 3 and 4 information. That's as simple as an access control list. So if we just write an access control list to permit all the hosts within the 192 network, allow them to go just to the internet. We're not worried about this host in here. We're going to use him in a little bit for our state tables. We will call him a web server though, right? But for right now, all we want to do is we want to say, okay, you know what? The hosts in here are allowed to go to web servers, any web, okay, any protocol using www. Okay. So in order to do that, we just IP access list. We're going to do extended, and the reason why is because we are going to filter on source, destination, and protocol or port. We're going to name this our web, and then under that you'll have the sub. Then we go ahead and we get to permit stuff. So we're going to permit TCP 192.168.1.0, and actually in a second we're going to put a wildcard there, so anything could have been there. And our wildcard mask 255. So this is our source. So anything going from. Now remember, a wildcard is directly opposite or inverse of a subnet mask. So here means we care about what's there, we care about what's there, we care about what's there, and anything could be right here. Okay, so our source, our wildcard, and then our destination. And we're going to say any, okay, so it can go anywhere as long as it's equal to www. So as long as our folks inside are going to the web using that protocol, then they're permitted. There is an implicit deny all at the end of any access list, right? We don't have to even type this in. I'm just putting it there as a reminder that at the end, so what's going to happen is we're going to, as packets come in from the 192 folks, if they're going to www, right, if they're going to this protocol, we're going to go ahead and let that through. Everything else will be denied. So if it comes from the outside trying to come in, it's going to get denied. If these folks up here at this point, if this guy here tries to do a file transfer, for example, he's not going to be allowed because we only permitted that. Okay. So these can get, packet filtering can actually, it's relatively simple to do, but it can also get awfully complex because there are likely other things that you want to do on the outside of your network other than go to the web. Okay. So it's just an example of packet filtering. Now let's go ahead. Can we just draw a line maybe? Let's just draw a line and ignore this for a second. So we looked at packet filtering. Now let's go ahead and look at kind of what a state table looks like. All right, so we have our access list in there, right, that permits everything from here to go to the web. So let's say now we're going to look at stateful firewall. Well, let's actually get a pen here. That would help. So he is what? He's port 80. The web, whoops. Let's try this again. Port 80. So 192, 168, this guy here, he is going to use, let's say his source port is 2101. So he's going out to this web server, 200.1.1.140, with a destination port, destination port of 80. Okay? Now, the access list that we have automatically allows this. A stateful firewall keeps track of the fact that from this inside, I think I said 12 and then I wrote 10, didn't I? Sorry. Probably doesn't matter. From this inside host here, he is using port 2101. No reason for that. I don't even know what the port it is on top of my head. Going out to the internet to pull a web page or something. Okay, then the destination port is 80. Wow, I am just not drawing right today, am I? Right, our destination port is 80. So now a dynamic ACL can be created to allow the traffic back in, because obviously if I'm going out to this server for something, I want it to be able to come back in. Because our stateful firewall keeps track of the fact that it originated in here and it was allowed, we're going to allow it to come back. So then a new dynamic, for example, ACL would be created to permit TCP host 200.1.1.140, right, equal to 80. So now my new source, so originally my source was this 192 on 2101 going out to the web, this particular guy on the web. Now, as long as the traffic's, now we're very particular, equal to port 80 is our source going to host 192.168 1.12 on port 2101 to make sure I wrote it down right. Our stateful firewall keeps track of that whole connection, right? And now we can create a dynamic ACL then that will allow that return traffic to come in, and our dynamic ACL would look like this. Permit TCP host 200.1.1.140 equal to 80, because that was our original destination port. It's basically just an inverse of the original to allow the traffic back in. Going to host 192.168 1.12 equal to 2101. So that will keep track of the state and allow us to dynamically create an ACL to permit the stuff back through. Okay. And then lastly, our application gateway, pretty simple thing. All we're going to do is, we're a little bit different now. Instead of this host here, maybe I should just get rid of some of this real quick. There, I got rid of some of it. Now, instead of this host going directly through, he's going to use a proxy. So we'll go ahead and draw our proxy server. And the proxy server is going to speak, in a sense, on behalf of, it's just different. I'm not even worried about this section right now. So don't even worry about this right now. Now we're just looking at our application gateway. We're just going to use our host and our web client. So now what happens is our computer makes a connection with our proxy, and then he makes a connection with the web server. And the communication happens between the host and the proxy, and then the proxy and the server. That means everyone out here, the only thing they're going to see is our proxy. Okay, so that would be our application gateway. Let's go ahead and look at some advantages and disadvantages of both packet filtering and stateful firewalls, and then go ahead and look just briefly at our next-gen firewalls. So the advantages of a packet filtering firewall is that it can do most of the things a firewall needs to do at a lower cost. Can't do all of them, but we can do most of them, right? And that's why we keep going through, and we get more and more advanced as we go through each of the topics here. Relatively easy to configure and implement. It's basic permit and deny statements. They have a lower impact on network performance, and they're available on most routers. So most routers support packet filtering. The disadvantages are that the ACLs that we write can become complex. So what started out as a very simple technology, basic permit and deny, most of us know at this point how to implement them, or we will very soon. Once you get the logic of it and you understand the logic of it, it's relatively easy. However, our simple basic thing that we did, right, that our little permit going to the web, that's pretty easy. Problem is that the implicit denial, chances are you want to permit or allow other traffic through your network. So they can become massively complex. They also can't dynamically filter some of the services, so applications that use multiple ports would require you to open a range of ports, which just puts more holes in your firewall. If you look at even the traditional term firewall, if we're trying to prevent a fire from spreading from one room to the other, and we've built a firewall there, the more holes we put through that wall, the greater the likelihood becomes that a fire will pass between the rooms, right? Will spread from room to room through those holes. It's the same thing with our networking firewall. If we create more permit statements or permit more ports or basically create more holes in our firewall, the greater the likelihood becomes that bad things come onto our network, whatever that is. If that's a particular hacker or malware, whatever that is, the more holes we create, the greater likelihood bad things are going to happen, right? So we say we can't dynamically filter some services. It is susceptible to IP spoofing because a malicious packet can be created that would be allowed. So like a hacker can, as long as it creates a packet that matches the permit filtering, then the packet will be permitted in, even though it may not be a good packet, right? I'm spoofing some legitimate user or host that's being allowed through the network, and then my packets will get through on that particular address. It doesn't keep track of the state, so only the packet itself is checked to see if it meets the requirements. No connection information is maintained, and it's not accurate with filtering fragmented packets because the very first fragment in a fragmented packet, it has the TCP information in it. So if that matches one of our statements or our filtering, then the rest of the fragments are let through. So if it matches a permit statement, then the rest of the fragments in that packet are allowed through. So the assumption is that all fragments are desirable on the network if the first one was, which might not be true. So it's not real accurate when trying to filter fragmented packets. Stateful firewalls, their advantages are better performance, has much stronger filtering because I can keep track of that connection or that state, and it can defend against spoofing and DOS attacks because it keeps track of the connection. It can see whether or not that packet comes from an authorized source. So if it didn't originally come from an authorized source, or it didn't start from the inside being permitted out, and that connection tries to come back through on that same permit IP address. Because it's keeping track of that connection, it knows it shouldn't be coming back through on that same IP address. So it can better defend against spoofing and DOS attacks, and more log information is provided. So the disadvantages then are it can't inspect at the application layer. So I might know that the packet coming through is using the www port or port 80, but I don't know what the content is of it. So I still could have bad content at the application layer. Some protocols, again, aren't stateful. So for example, UDP, right? That's connectionless, it's stateless, so we're not keeping track of the state. ICMP is the same way. It's not stateful, so it's not going, a stateful firewall is not going to be very useful with those protocols. Dynamic port negotiation, again, requires a range of ports to be open. Same thing with the packet filtering. If we do dynamic port negotiation, it's going to require us to open a range of ports, thereby creating a larger hole in our wall. And it doesn't support user authentication. So those are some of the disadvantages. Now, the last thing we want to do is just briefly look over next-gen or next-generation firewalls that are going to combine a bunch of different technologies and capabilities. And you could do a whole ton of study on them. And we'll look at them a little more later. I'm just going to look at them briefly here. But they combine a bunch of technologies together in that one box or that one device to do all the things that we need to do. So layers 1 through 7 are inspected, and it can be deeply looked into, so we call it deep packet inspection. Creates high visibility. Websites or web applications can be denied based upon the reputation of the site. So if it's a known bad location or a known bad site, it won't be allowed through, right? It won't get into our network. We do malware detection at all kinds of different levels. We can do NAT and VPN over this device, and we can do intrusion prevention over this device. Policies can be enforced by users regardless of IP address, device, role, or application type. There's just a lot of really cool things we can do, and we'll hit some of them here. We won't hit all of them. Some of these are much more advanced than we'll get through, but we will get through some of them as we go through the course. And that's it.